Thank you for joining us. This session is to discuss the online and part-time graduate programs in materials science and engineering offered through the Whiting School of Engineering at Johns Hopkins University. My name is Cheryl Williams. I am the Assistant Director of Recruitment and Marketing for the Whiting School. To give us more information on material science and engineering, I have with me our chair, Dr. James Spicer.
Yes, so material science and engineering. Our program is part of materials at Hopkins, which is a pretty broad landscape. We have our full-time programs, BS, MS, and PhD, and our EP master's program coordinates closely with our full-time master's program. And materials, though, at Hopkins goes beyond material science and engineering, and you find materials represented in other programs, including mechanical engineering, electrical engineering, and applied physics. So in our materials program in EP, we have a Master of Material Science and Engineering. That's the only degree program that we offer. In this program, you're required to complete 10 courses, and generally students finish those 10 courses in 2 to 3 years, and you have up to 5 years to finish them. We have 3 semesters during the year, or 3 terms during the year, a fall semester, a spring semester, and a summer term, and you can take classes essentially year-round if you want. In our materials program, though, we have a couple of focus areas that some students choose to pursue, one being biotechnology and second being nanomaterials. And basically, in these focus areas, we've identified courses within EP that you can take to essentially enhance your knowledge in these 2 particular areas. And in nanotechnology in particular, the materials program offers a concentration. So if you're really interested in nanotechnology, we have a couple of courses within the materials program that we call core classes, and I'll talk more about those later. And in addition to other program requirements, in order to get the concentration noted on your transcript, you would have to take those specific classes in nanotechnology that we offer. And in terms of where our courses are offered, you know, we have classes that are taught at the Johns Hopkins Applied Physics Laboratory and at the Homewood campus in Baltimore. And we also have offerings that are online. And starting in fall of 2019, you should be able to complete your material science and engineering degree in EP completely online, which we're really excited about. So what areas do we focus on in materials in our department and in our program? One of our focus areas is in biomaterials. Being at Johns Hopkins, there are connections to bio-related engineering in most programs and departments, and our department is no exception in that biomaterials are well represented at Johns Hopkins, not only in materials, but also in biomedical engineering, applied biomedical engineering, and in electrical engineering as well. Nanomaterials, again, that's widely represented in material science here at Hopkins, as well as other departments, including electrical engineering. Energy materials, computational material science is a large part of our program. And you'll also find research in areas related to polymers and structural materials, and especially we have the Hopkins Extreme Materials Institute, and when you talk about structural materials, especially serving in extreme environments, HEMI as we call it, is a real focused area for research in that area. And HEMI is one of the institutes here at Hopkins that has a real materials bent, but there are other research centers and institutes where materials research occurs, both at the university in Baltimore as well as at the Applied Physics Laboratory. Oh, my research. Okay, so this is a busy slide, and I appreciate that. I think what you should get from this is that in materials, a large focus is in nanostructured materials, and my program is no exception to that. And we've been working a number of years on trying to create these functional materials that can be used in energy applications, especially for like photochromic materials or photocatalytic materials. And we have interesting processing routes that we use to try to make these materials in an economical, affordable way. All too often, magical materials are made that have great properties, but you can only make a small amount. And what we've been focusing on is processing of nanostructured materials and addressing that scale-up issue, which is a real problem when you talk about practical applications of these materials. Oh, and additive manufacturing of ceramics. So yes, in my research group, we're pursuing additive manufacturing. This is a very important area in manufacturing technology and in material science. And in my particular group, we're trying to address additive manufacturing of non-oxide ceramics, which is a difficult research area, and people who do additive manufacturing generally focus in metals or in polymers, because doing rapid prototyping or additive manufacturing using those materials is relatively easy. Not so much about ceramics, and that's why some material scientists have to do some heavy lifting before we can truly produce ceramics using additive manufacturing techniques. Within our EP program, though, in materials, we have a sequence of courses specifically dedicated to additive manufacturing, and a lot of our students are taking that sequence of courses to really get a better understanding of where additive manufacturing might play a role in various industries or in areas where they're interested. So our student body, who is taking classes with us? Well, as you can see on the slide, the average age is about 26 years old, 90% are employed at a range of businesses or government labs or just with government. So we have students from the Applied Physics Laboratory from Northrop Grumman, which is nearby, from GE, from Textron, and the list goes on. In the past, most of our students have been drawn from businesses that are in the Baltimore, Washington area, because our students were not able to complete their degree program online. And so some of our courses they needed to take in a face-to-face modality. But now that we're going to be offering online courses for our students, will be able to have students from other places across the United States, and they'll be able to complete their degrees online with us. So you see there's a total of 31 students in our program right now. That's not unusual for a master's program at a research university to have that number of master's students. We have essentially that same number in our full-time program, master's program, and that gives us a nice student to faculty ratio, both in our full-time program and in our EP program. And it's a nice environment where if you're local and you can connect directly with our faculty members and meet with them. And as we move online, obviously that number will grow, but we're hoping that we'll be able to maintain that kind of personal contact with our students. So our degree program, what do you have to do to complete your degree? Well, again, it's 10 courses. You have to finish those within 5 years. We have 2 core classes in material science and engineering that you have to complete. The first one being structure and properties of material, and the second one is thermodynamics and kinetics of materials. The one course is offered in the fall. The second course is offered in the spring. And generally what our students do is they take 1 or 2 courses a semester or a term, and they take structure first, and then they take kinetics or thermodynamics and kinetics their second term here. And then they're able to take just about any other course in materials that might have those as prerequisites. Some students with materials backgrounds are able to start taking some of our classes without necessarily taking those core classes. So when you look at the 8 elective courses that you have to take, some of those have prerequisites that might be our core classes. And if you have a background in materials, you might not have to take those core classes before taking some of the other materials classes in our program. And if you don't necessarily have a materials background, there might be an opportunity to take materials courses even online before taking our core classes. So there are a range of options open to you when you start our degree program. And as you're finishing our degree program, many students decide that they want to engage in a mentored research project. So 2 of your 8 elective courses could be like a project course that you set up with an instructor in EP or in the full-time program. And that project can either be a research project in one of our laboratories if you're local, or it could be a project that is of a research flavor at your workplace. And in consultation with your project advisor, you will come up with a course plan essentially, and what the requirements of that research project course would be. So again, two of your courses could be that kind of research project. So our biotechnology focus, you can pick your courses, some of your elective courses, or all of your elective courses from ones that are offered in biomaterials here at Hopkins, either in EP or in our full-time program. So Biomaterials 2, Host Response and Biomaterials Applications, that's a course that's offered every year. Chemical and Biological Properties of Materials, that's a graduate level course that's offered every year. And then there are other courses in the Whiting School or in EP that you could take that are related to biomaterials. So you see there are courses that are in Applied Biomedical Engineering, which are offered through EP that are online, as well as other ones that you can take that are person-to-person or face-to-face. Also, there are courses taught in either material science and engineering or biomedical engineering that are at the Homewood campus that you can take, like Introduction to Biomechanics, that's in mechanical engineering, supramolecular materials and nanomedicine, that's in chemical and biomolecular engineering, tissue engineering, cellular engineering, and the list goes on and on. This is just a sampling of the courses that could be offered during either the fall or spring terms. And then the nanomaterials focus, again, there are a range of courses either in materials or outside the materials department and the materials program that relate to nanomaterials that you could take. And some of these are listed here. Some of them are offered in our chemical and biomolecular engineering department. Others are in electrical engineering. And you can see that some of them are offered through EP and others are at Homewood. So other courses that you can take, materials characterization, electrical, optical, and magnetic properties, physical properties, mechanical properties, additive manufacturing. Some of these are online, like mechanical properties. You can take that online, or you can take it face-to-face in person if you want. But then there are other courses that you can take as electives that are online. Many of these are taught out of other programs in EP. So here's 3 that are listed in particular out of mechanical engineering: strength of materials, polymeric materials, and symmetries of crystalline solids. All of those are genuinely materials courses, but they just happen to be offered out of our mechanical engineering program, and all of them are online and available for you to take. Within the EP program on materials, you can choose to concentrate in nanotechnology, and I mentioned that previously. And in order to complete this concentration, not only do you have to complete the 2 core classes in materials that everyone has to complete, structure and properties and thermodynamics and kinetics, but there are 2 additional core classes that you have to complete. One of them is Introduction to Nanotechnology. That course is currently taught online. And then the second course is Nanomaterials, and that one will be offered for the first time online starting in fall of 2019. So these 4 core classes need to be completed to get your nanotechnology concentration. And then you would have to complete 6 additional elective courses. And they should be related to nanotechnology, but they can be more broadly based in materials as well. So our online courses, we're bringing more and more to you in the online format. So the plan is in spring of 2019, we would have thermodynamics and kinetics online, and hopefully we're able to pull that off. If we're not, then that course will be delayed by a year. Nanomaterials should be online starting in summer 2019, but probably won't be offered in the summer. It'll likely be offered in the fall of 2019, we'll see. But then structure and properties of materials, which is our first core class, that will be online in fall of 2019. And then we have some very interesting new courses that are debuting this spring. One of them is Additive Manufacturing Materials and Processes. And this is the third course in our Additive Manufacturing sequence. The first two, one is an introduction to additive manufacturing, and the other one is design in additive manufacturing. And then there's this course on additive manufacturing materials and processes. So that sequence of three courses kind of brings you up to speed with the state of the art in practicing additive manufacturing in the workplace, which is kind of cool. And then we have another new course, which I believe is the first metamaterials course being taught at Hopkins to our graduate students, and that's fundamentals of metamaterials. Very exciting area, and we have a new researcher from the Johns Hopkins Applied Physics Laboratory who's going to be teaching that class for us.
All right. Thank you, Jim. Now we'd like to take just a couple of minutes to talk through the application process for this program. If you are interested in applying for this program, there are three components to a completed application. That being first, an online application, which you can complete by visiting the URL that you see here on your screen, ep.jhu.edu/apply. And then in addition to your online application, we would need your academic transcripts and your professional resume. Instructions on where to submit these documents can be found in the text that's just above the application form. For our online and part-time programs, we actually offer rolling admissions. So you can be admitted to this program in any of our semesters that include the fall, spring, and summer semesters. So because we offer rolling admissions, we do not have hard application deadlines. What we wanted to share in lieu of an application deadline is kind of the how long the application review process takes, and then some important dates. So it typically takes us about 4 to 6 weeks to review a student's completed application package. And just to keep in mind with some important dates for the spring 2019 semester, our spring registration is actually already open. It opened on the 25th, and our spring semester starts on January the 28th. So if you are interested in starting in the spring 2019 semester, I'd encourage you to submit your application materials as soon as possible, ideally by mid-November if possible, so we could review and issue a decision letter prior to the start of classes. Jim, would you like to talk a little bit about the admissions requirements for your program?
Oh yeah, so people come into materials with a lot of different backgrounds, and you know, it's rare that one of our students would actually come to us with an undergraduate degree in material science and engineering. But we do like to have students who do have a background in the sciences or engineering who apply to our program, because generally they have the courses in their background in their previous program of study that will allow them to succeed in material science and engineering. So you can see the prerequisite coursework that we typically look for: calculus and standard calculus sequence, general physics, general chemistry. And if you have a solid foundation in your math, physics, and chemistry, chances are you're going to be successful in our program. And you know, we do look at your GPA, because it's, you know, if your GPA is 3.0 or higher, then we can be fairly confident that you're going to get through the program successfully. And that's what everybody wants. Every student that we admit into our program, we want to feel confident that they're able to complete it. And so, yeah, we do look at that GPA, and we look for those courses in your background. Some people really have a strong case for admission to our program. Others, maybe, they're a little bit weak in an area, their GPA might not be high in their core science and math, or they might not have a preparation that really will help them succeed in some of our core classes because they haven't seen some of the concepts before. And in the application process, you're encouraged to submit your resume. And I'll add to that if you feel that you want to make a stronger case for admission, and your case is weak, namely that your GPA is on the low side, maybe you don't have a full suite of materials courses in your background, you might want to include letters of recommendation from your supervisors so that we have a better understanding of what you're able to accomplish in the workplace and how that might translate into your success in our program, and also how participation in our program will help you in your career development. That's always useful to know, and if your supervisor can point to how this might happen, that can be useful. So some things to keep in mind while you're putting in your applications.